Okay, Algebra 2, we're looking at lesson 2-3, part 2. And we just we finished talking about rate of change in the last video. And now we're going to talk about parallel and perpendicular lines. So the thing about parallel lines is parallel lines have the same slope. So if line A is parallel to line B, right, then the slope of A has to equal to the slope of B. All right. Yeah, so basically that's what we know. So they want us to graph the line through this point that is parallel to the line with this equation. And so what would be really helpful is if I knew what the slope of this bad boy was. What's the slope of this line? Because if I know that, then I know I'm just graphing a line through this point and through the slope that I'm going to get from here. So I'm going to find the slope. And one neat way to find the slope is to just put this bad boy in slope-intercept form. If you recall, slope-intercept form is y equals mx plus b. So if we solve for y, push everything over to the side, simplify it such that the x term is first, the m value will be the slope. Let's do it. So I need to get the x value over here, get the x out of here, right? So 4y equals negative x minus 4. And then we're going to divide both sides by 4. Notice I said divide both sides by 4. That means everything got to be divided by 4. So this is a negative x over 4 minus 4 over 4. Simplify that. Y is equal to negative 1/4 x. Y'all see that there's a negative 1 here and a 4 here, negative 1/4 x minus 1. Now that we've got this together, I'm going to just drag it over here so we can talk about it more. Now that we've got this, we know that the only thing we cared about when we came into this problem was to figure out what the slope was. This negative 1 does not have anything to do with us. We just did the thing. We got the y-intercept of this line, but ain't nobody asked you about that. So now we've got the slope and we've got the point. I need to find an equation, or I need to graph the line that has this point and this slope. Let's do it. So the first thing I want to do is find that point. And so I need to locate the point by going to negative 1, positive 3. 1, 2, 3. All right, so there's the point, right? That bright yellow dot on your screen. Let me put a little black dot in the middle so you can see it. All right, so negative 1, 3. Now we're going to use the slope. Let's talk about slope real quick. So we know that the slope is equal to negative 1/4. And I can write negative 1/4 as a negative 1 over 4, or I can write it as a 1 over negative 4. Take a minute to breathe that in. Now that we have this, sometimes I call slopes direction. It gives me direction as to how I'm supposed to move from a given point. So if I look at this slope here, right here, and I have circled in red, it tells me my rise is negative 1, so that's a drop. And my run is positive 4. I'm moving positive to the right, right? So drop 1, go over to the right 4. 1, 2, 3, 4, and that's my first point. If I use this slope, I can do it again. Down 1, go over 4. 1, 2, 3, 4, and I'm right here. Now, if I had chosen to use this one, I would have started at that point. Notice that the rise is positive. Go up 1, but the run is negative. I'm going to go to the negative direction on the x-axis, going back. So up 1, back 4. 1, 2, 3, 4, and I land here. What you should notice is that all these points are all collinear. They all land on the same line. I can keep doing it. Up 1, back 4. But the fact of the matter is, the reason why I wanted to explain this is so you can really look at how to deal with a negative slope. You throw the negative, if you're going to use the slope to navigate through your XY coordinate plane, you throw the negative on either the numerator or the denominator, given direction of either going up or down or left or right for your X and Y axis. Does that make sense? All right, I hope so, baby. All right, so I'm drawing this line, kind of okay. Here's my slope, my line, and the slope is negative 1/4, and it did go through the point negative 1, 3. We did it. Let's look at this next one. So perpendicular lines are a different beast altogether. Perpendicular lines are lines that intersect and form a right angle. Let me do it this way. So let's pretend that this is the X and Y axis. They are perpendicular lines, but let's see if we can draw some other perpendicular lines. Here, these oblique lines, they're neither horizontal nor vertical, are perpendicular if they form a right angle. You guys with me? So let's talk about what their relationship is in terms of their slope. So if the slope of a line is like a over b, some fraction a over b, then the slope of a line perpendicular to it is going to be negative b over a. What I want you to observe is that it is the opposite sign, and you flip that fraction or that relationship, that the numerator and denominator of the slope is the opposite reciprocal. You guys with me? So let's see if we can answer the question with this new information. Graph the line through negative 3, 1 that is perpendicular to the line with the given equation. All right, so just like last time, what we needed from this line is its slope. And we're going to do something a little bit different. But first, let's find the slope. So finding the slope, I'm going to put this equation in y equals mx plus b form, because that's how it's very simple for me to do in order to find the slope. I need to isolate the y term. So I'm going to get the add negative 2x's to both sides, getting the 2x's out of there. 5y is equal to negative 2x plus 10. I'm going to divide both sides by 5. Y is therefore equal to negative 2/5 x plus, not 10, but 2. Notice the 5 needs to divide into both of those, okay? Now that we have this, we've got a slope. We've got a slope. And the slope happens to be negative, let me make it a little bit bigger, negative 2/5. But this is not the slope we want. This is the slope we got, but we need the slope. We need to find the slope of a perpendicular line to this line. Are you with me? So how do we do it? Well, we remember, if the slope of the line we're talking about is some a over b, the slope of the line perpendicular to it is the opposite reciprocal, or negative b over a. So I got to change the sign and flip it. So the slope of the line that that's not it. The slope of the line that we are looking for or talking about is going to be perpendicular, and it's going to be 5 over 2. Positive 5 over 2. Do you see that relationship there? It is the opposite sign, and it is reciprocated. It's flipped over. All right, so this is the slope that I'm really interested in. This is the slope that I want. All right, so I want this slope. I'm going to highlight it in red, and I want this point. And now I'm going to graph that line. So the first thing I'll do is locate this point, negative 3. Let's go ahead and put a dot there. Negative 3, 1, 2, 3, positive 1. That's here. And the next thing I'm going to do is use the slope as my guide, as my pathfinder, as my map. I'm going to go rise 5, 1, 2, 3, 4, 5, right? And then I'm going to run 2, 1, 2, and that puts me right about here. And I can continue that if I wanted to, just for argument's sake. I could look at this as negative 5 over negative 2, which is still positive 5 halves. And then I would get the point, go down 5, 1, 2, 3, 4, 5, and go in the negative direction too. 1, 2, and that would bring me here. Notice that all of these lines are indeed collinear. And so that means they just all lay on the same line. I'm going to try my best. You saw I struggled with that one. But we have this slope, and we did the thing we were supposed to do. We did it, and we've come to the end of our section 2-3 video. Let me know if there's any questions or comments or concerns. I look forward to talking to you soon, and see if this helps you out with the assigned problems. All right, sweeties, take care. Bye-bye.